question 1 gives us an inverse demand function as well as a total revenue function and total cost function, and then asks us to use these to determine which of the following statements are incorrect. So what we're going to do is we're going to look at each of these answers A, B, C, and D, establish whether it is correct or incorrect, and then from that deduction be able to decide which of these answers is true with respect to the question which is looking for an incorrect answer. So what we have is this function of a demand curve. So this tells us the function of the demand curve. We refer to it as the inverse demand function because demand, quantity demanded, depends on price. If we inverse this function to have price on the left-hand side and quantity demanded on the right-hand side, then we are plotting our demand curve. So what we're going to do Question A then asks, is the marginal revenue function MR equals 100 minus 4Q? So how are we going to find the marginal revenue function using the information we have? What we can use is our existing demand curve, because from the theory in core, we know that demand and marginal revenue have the same y-intercept. And we can prove mathematically that the slope of our marginal revenue curve is twice as large as the slope of the demand curve. So MR slope is twice as large as the slope of the demand curve. And the way we can confirm that is if I take a demand curve, so the one that I have up here, 100 minus 2Q, and I calculate my total revenue function, which is going to be price times quantity. So then what I can do is just multiply this through by Q. And so I'd get 100Q minus 2Q squared. And then I can recognize that my marginal revenue is the first derivative of my total revenue. And so if taking the first derivative of 100Q with respect to Q gives me 100. The first derivative of minus 2Q squared with respect to Q is minus 4Q. So this is my marginal revenue function. And here I can confirm that the intercept is the same as the intercept of my demand curve, and the slope of my marginal revenue is 2 times as large as the slope of my demand curve. So looking at A, it says MR equals 100 minus 4Q. That is correct, which makes it incorrect for this question because we're looking for an incorrect answer. B then says the average cost function is AC equals 200 plus 200 over Q. So AC is equal to TC over Q. We calculate average cost by taking our total costs and spreading them all over output. So if I take my total cost function here, 100Q minus 2Q squared, sorry, that's my total revenue function. If I take my total cost function, which is 20Q plus 200 over Q, I'll have 20 plus 200 over Q. And that is exactly the average cost function I have here. So that is a correct statement, which makes it incorrect for this question. Then I look at C. C says the marginal cost function is MC equals 20 plus 200. So we found AC by taking TC and dividing it by Q. MC is going to be the first derivative of TC. So if I take the first derivative of 20Q, I'd get 20. And the first derivative of this constant 200 would be 0. And so this statement here is incorrect. MC is equal to 20. And so this is a correct answer for this particular question. Then just to confirm that D is incorrect, the profit maximizing quantity of output is 20 units. So we would find the profit maximizing quantity when MR equals MC. This is our MR, 100 minus 4Q, and our MC is 20. So AT equals 4Q, and that tells us that our profit maximizing quantity is 20. So this is a correct statement, which makes it incorrect for this question. So the answer to question 1 is C. In question 2, we're following with this total cost theory, or the cost theory, and we get given this total cost function here. Total cost is 150,000 plus 30Q plus 3Q squared. The marginal cost of producing the 20th unit is. So if we get given a total cost function like this, we can find our marginal cost function as the first derivative of this total cost. Taking the first derivative of this function here, 150,000 derived with respect to Q would be 0. 30Q derived with respect to Q would be 30. And 3Q squared derived would be 6Q. So this is my marginal cost function. What I can do now is take 20 and sub that in for Q. So the marginal cost function is simply that upward sloping linear line that we would have seen throughout the graphs shown in units 7 and 8. So the intercept is 30 and the slope is 6. If we want to know what the marginal cost of the 20th unit is, then we're trying to solve for this value here. And so we sub in 20, so 30 plus 6 times 20 would give me 150. So this value over here would be 150 according to this marginal cost function. And so the answer to question 2 is B. The alternative thing that this question could have asked us for is for the average cost. And so we would then divide this total cost function by Q and then sub in whichever unit the question would require the average cost for. So that's how we work with a cost function in order to find marginal cost, and how we could also use it to find average cost. Okay, so now question 3 gives us some information about a producer of hats that she sells at 250 Rand per hat. So the price is 250. During the month of April, she sold 100 hats. So that's my quantity. And made an economic profit of 10,000. So profit is equal to 10,000. If she produces the hats at a constant per unit cost. So what does it mean to have a constant per unit cost? It means that the average cost of production is constant at some value. And if the average cost is constant, then the marginal cost would also be constant. So think of it this way. Let's say the average cost is, I'll just choose some value down here. Let's say it is 250. Then it means total cost would be 250 times Q. And then if I took the first derivative of this to find my marginal cost, it would simply be 250. So when we have a constant cost of production, then our marginal cost is also constant. So that's just a little bit of theory to remind you about that. So using the data here, we need to figure out what the average total cost of producing a hat is. So we get told that profit is 10,000, and we can calculate profit as price minus AC times Q. if I look at this function here, I have my Q and I have my price. And so if I sub in price of 250 and quantity of 100, I can very quickly solve for AC. So 10,000 is equal to 250 minus my unknown cost times 100. If I divide both sides by 100, I get 100 is equal to 250 minus AC. And so that means that AC is equal to 250 minus 100, which is 150. And so the answer is D, 150 Rand. There is an alternative method that I could have used. So profits can be given by this function here, price minus AC times Q, but it can also be calculated as TR minus TC, so total revenue minus total cost. So I could have also written 10,000 is equal to 250 times 100, which is my total revenue, minus total cost. And then I would have found that total cost is equal to 25,000 minus 10,000. So total cost is 15,000. Average cost would then be total cost over Q. And so it would be 15,000 over 100, which would give me the same answer, 150. So these two methods would give you an identical answer of 150. Okay, moving on to question 4. An unregulated monopolist. So there's something very specific about unregulated, and then there's also something specific about monopolist. So unregulated means no government intervention. In other words, we're assuming there is no tax or price controls or any other intervention that a government could apply to a market. A monopolist implies a differentiated product. And if you are producing a differentiated product, that means you're able to set a price according to your consumer's willingness to pay. So you don't have to take a market price as given. You have price setting ability. You have some power. So the monopolist will produce a quantity at which MR is equal to. So if you are any firm in the context of the core theory that we've been teaching you, the goal is to maximize profit. How do we maximize profit? Where MR equals MC. So this should be MC. Okay, and what we can see is that the only answer here that has MC is C. So by process of elimination, the answer has to be C. But its price is equal to, and so the price that a price setting firm is able to charge for its profit maximizing quantity is according to the willingness to pay of its consumers. So if we look at the picture for monopolist, they would have a downward sloping demand curve and a downward sloping marginal revenue curve that would share the same slope, the same intercept as the demand curve. We have price and quantity. We can also put costs on the y-axis as well because we're plotting a firm. They then face an upward sloping marginal cost curve. They choose to produce the quantity where MR equals MC because that's the quantity that profit maximizes. They then are able to choose the maximum price that their consumers are willing to pay for this quantity. And that's how we end up stating that price is equal to willingness to pay. And so the answer here is C. Just to remind you where this profit maximizing rule comes from. So profit is total revenue minus total cost. If you're looking for a max, so a maximum of a function, you're going to find where its first derivative is 0. So if I take the first derivative of this function here, I'm going to have the first derivative of total revenue is going to be marginal revenue, and the first derivative of total cost is going to be marginal cost. and I want to solve for where this is 0. And so if maximum profit means MR minus MC must be equal to 0, then that's the same as me saying that MR must be equal to MC. So this is where the profit maximizing rule, MR equals MC, comes from. The other thing that we can look at in this picture is at this profit maximizing quantity, they're able to charge this price. This price exceeds the marginal cost of the last unit produced and sold, and we call this difference the profit margin. So it is the profit that is made at the margin for the last unit produced and sold. So profit on a unit is price minus AC. The profit margin, so the profit on the last unit produced, is price minus MC. So that's the distinction between profit and profit margin. Okay, so question 5. Mary is a producer of a differentiated product, and so that makes her a price setter. And we can see from the demand curve given, and in actual fact, technically this is not correct. This is not the function of a demand curve. This is the demand function because we're having quantity as a function of price. For this to be the demand curve, we would have to inverse it. Okay, so technically stating that this is the demand curve is not absolutely correct. It should have said the demand function. So we get given the demand function of this price setter, and they want to know what is her marginal revenue function. Okay, now I'm going to show you the correct way to do this, and then I'm going to show you a common mistake that might be made when dealing with this kind of problem. So what we have is a demand function that we then need to inverse to find the function of the demand curve. And the reason why we need the function of the demand curve is because if we have the demand curve, which has price on the y-axis and Q on the x-axis, once we have this function, we can very quickly find our marginal revenue function because it will have the same y-intercept, but it will be twice as steep as our demand curve. So the first thing I'm going to do is inverse this function here. So 4p equals 160 minus Q. And so price is equal to 40 minus a quarter Q. So this is my demand curve. That means my marginal revenue will have the same intercept of 40. And if the demand curve has a slope of minus a quarter, then the slope of the marginal revenue curve is going to be twice as large as this. And so it's going to be minus a quarter times 2, which is minus a half. And so this is the function of marginal revenue. And if I look at the options provided above, and there was a bit of a printing error here, so actually this should be 1 over 8, 1 over 8, 1 over 2, 1 over 4. So looking at these options here, the one that matches my calculations is C, MR equals 40 minus a half Q. So the answer is C. So one of the common mistakes that students might make in this question, and if you do this question this way, you'll see that there are no answers here that match what you end up with, is the following. So MR is the first derivative of total revenue. That's something that I think we all accept very readily. If we look at this function here, we get given Q as a function of price. And so what we might think then is that total revenue, being price times quantity, could be written as 160 price minus 4 price squared. So what I'm doing is I'm taking price and multiplying it through by this quantity function. So I would say total revenue is 160p minus 4p squared. And if I take the first derivative of this, I would say that marginal revenue is 160 minus 8p. That is incorrect And the reason why is because all of the functions that we work with in the theory of the firm are functions of quantity, because that is the decision that is having to be made by the firm. The ultimate decision is, what quantity must I produce to maximize my profits? And once I know that, then all the decisions about price can follow. So that means that total cost is a function of quantity. Total revenue is a function of quantity. Price is a function of quantity. Marginal revenue is a function of quantity. Marginal cost is a function of quantity. Average cost is a function of quantity, etc., etc. Profits ends up being a function of quantity. So all of these depend on the choice of quantity. If we look at this function here, marginal revenue is a function of price. That would not assist us in solving for our true variable of interest, which is the quantity that the firm needs to produce in order to profit maximize. So if you get given a demand function and you have to work out marginal revenue, your first step should be to inverse this to get the demand curve. So you need to be working with functions that have quantity on the right-hand side. So that's just to show you what to avoid as a potential mistake in an assessment. And question 6 works again with this idea. So I'm going to show you again what I mean by first having to inverse the demand curve, demand function in order to get your marginal revenue function. So we have a monopoly that faces the following total cost and demand functions. So what is a monopoly? A monopoly is a price setter that is the sole firm in a market. So what we can actually say is that the monopoly is the market. The demand curve in a market, which is a monopoly, will be the firm's demand curve. And that is different from other firms. So whenever there's an element of competition in a market, then the demand curve of a firm will not be the market demand curve, because we'd have to find the market demand curve by adding up everybody's individual demands. Okay, so a monopoly is a price setter, and it is the only firm in an industry. And the reason why they tend to be the only firm is because of high barriers to entry and exit. So that's what establishes its monopoly power. Okay, so the monopoly faces these functions. We now are asked to write down a function for the firm's marginal cost. So marginal cost is the first derivative of total cost. So if I take the first derivative of this, first derivative of 100 with respect to q becomes 0. 3q derived is 3, and 0.5q squared. The 2 will come down to the front, so it become 1 times q. This will reduce by 1, so it would simply be 3 plus q. So there's the marginal cost function. Now they want you to write down a function with the firm's marginal revenue. And this is out of 2 marks, which means there is going to be a little bit more work involved than calculating marginal cost. So as I said in the previous question, in order to get marginal revenue, I first need my demand curve function. So I need to inverse this. That will then give me my demand curve, and once I have my demand curve, very straightforward to get marginal revenue. So if I inverse this, I'm going to have 4p equals 240 minus q. And so price is going to be 60 minus a quarter q. So this is the demand curve. And then just using everything we've learned up until now, my marginal revenue will have the same intercept, and the slope will be twice the demand curve slope. So 2 times a quarter gives me a half. And so this is the marginal revenue function. Then it asks us to calculate the firm's profit maximizing quantity and price. So we find the profit maximizing quantity by setting MR equal to MC. MR is 60 minus a half Q. MC is 3 plus Q. So now I solve for Q and I get 60. I take the 3 to the side and I get 57 equals. Minus a half becomes a plus half, so that's 3 over 2Q. and that then gives me 57. If I divide both sides by 3/2, I'm going to get 38. Is it 38? Yes, 38 equals Q. Because it will be 57 divided by 3, which is 19, and 19 times 2 is 38. So that's the profit maximizing quantity. How would I then find the price at this quantity? So I need to recognize that what I've just solved for is this point over here, MR equals MC. And so this is 38. What price is the firm going to charge? They're going to charge the maximum price their consumers are willing to pay. So I need to put 38 into the demand function. So here, price equals 60 minus a quarter Q. And so price is going to be 60 minus a quarter times 38. A quarter of 38 is going to be 9 Rand 50. And so the price is going to be 50 Rand 50. Okay, now I've put a rand there, but technically we don't know what currency this question is using because no currency is given. So I'm just going to assume that it is a rand. Okay, so the price is 50.50. Then it asks us to calculate the firm's profit margin price minus MC. So we have price, which is 50.50. So that's the price. And now we need the marginal cost. So what we want is this value at a quantity of 38. So we sub 38 into our marginal cost function. So 3 plus 38. So our marginal cost at 38 is 41. And so our profit margin is going to be 9.50. 50.50 minus 41. And then part E, the final part of this question, asks us to calculate the firm's total economic profit. So the easiest way to calculate this is going to use the total revenue minus total cost formula. Total revenue is price times quantity. Price is 50.50, quantity is 38. So that's the total revenue. And then to get the total cost, I'm going to sub 38 into this total cost function up here. And so total cost is going to be 100 plus 3 times 38 plus 0.5 times 38 squared. And using my calculator to solve for this, I will have total revenue is 1919 and total cost is going to be 38 times 38 times 0.5 plus 3 times 38 plus 100, and that's 936. And so we end up getting a total profit of 983. Okay, so this is a really nice question that uses all of the solutions to find the pricing, quantity, and profit maximization, the profit margin, and then the total economic profit. So what this tells us is that this firm makes positive economic profits. And so the price in equilibrium, so the profit maximizing equilibrium of this firm, exceeds the average cost. So price must exceed average cost at the profit maximizing quantity for us to end up with a positive profit. So if I had to represent that on this picture, my AC curve would lie at a point that gives me an AC that is below my price at that profit maximizing quantity. So I could very quickly calculate my average cost. So what I know is that my total cost is 936. That's what I just calculated when I did the last question. And so 936 divided by 38, which is the quantity, gives me 24.63. So in other words, my average cost is somewhere down here. And so if I had to plot in my average cost curve, it would look, it's going to be a bit tricky to draw, but it's going to look something like this. So that would be, we would never ask you to plot an AC curve for exact values. We'd only ever ask you to plot it theoretically, because that was very difficult for me to draw to try and ensure that this is the minimum point of the AC. But I just wanted to show you how it could look if we end up with a positive economic profit. And then in this picture, I could color in my profit as the price less the AC times the quantity. So this block here would represent the positive economic profits of this monopoly firm. And the interesting thing about this is that this positive economic profits could be made in the long run because of the high barriers to entry and exit. And that's different to any kind of competitive firm, whether it is perfectly competitive or monopolistically competitive, because those firms are not able to make positive economic profits into the long run. They are limited to zero economic profits or normal profits in the long run. Okay, so what we've covered mostly up until now are monopolists, so firms that face downward sloping demand curves. What I'm now going to move into is some theory about perfect competition. So I'm going to start with perfectly competitive markets, and then we're going to move into perfectly competitive firms. So I'm first going to start off with some theory of where market demands, so downward sloping market demand curves in perfect competition, come from. So our market demand in perfectly competitive markets is downward sloping because of the law of demand. If price is lowered, quantity demanded would go up. And if price was raised, quantity demanded would go down. So that's the law of demand. Higher prices lead to lower quantity demanded, and lower prices lead to higher quantity demanded. What we're showing is that when price changes and nothing else that influences demand is changing, that is us moving along a demand curve. So a change in the price of a product moves us along a demand curve. It doesn't shift the demand curve. A demand curve describes the entire relationship between different quantities that are demanded at different prices over a certain period of time. So when we talk about demand changing, what we're saying is that this entire relationship changes. When quantity demanded changes, we simply mean that the price value has changed. So this variable has changed to cause this variable to change. Okay, so using that, we're going to go to the question. So the question says, which of the following factors can shift the demand curve of a good? So a shift is to imply that the entire demand curve moves. And when the entire demand curve moves, it means that holding price constant, so keeping price at price 1, the amount that people choose to buy at that price has changed. Okay, and so let's think about what would cause that. So 1 says a change in consumer preferences. So let's say that we have this demand curve and we're going to plot My Brew's coffee. So My Brew faces the following demand, and let's say that My Brew charges this price, 24 Rand on average. And so many people, let's say 1,000 coffees are bought and sold a day. Okay. My Brew then invests in an advertising campaign. So My Brew tries to increase people's desire for their coffee, how would that affect this picture? So when MyBrew advertises, they're not changing their price necessarily. I mean, we know that price discounts could be used to encourage people to buy, but that would be us moving down the demand curve, right? We would just lower the price and move ourselves down the demand curve. But what I'm saying now is they're holding their price constant, but they're just introducing some marketing campaign that increases how much coffee people buy at their current price. So if this marketing campaign is successful and they're able to increase people's preferences towards MyBrew coffee away from, say, Vida or DCM, then they might find that they're able to sell more coffees a day. That means that this 1,000 is no longer the quantity demanded at a price of 24. The quantity demanded has increased. And that could be represented by a shift rightwards of MyBrew's demand curve. And so a change in consumer preferences does shift the demand curve of a product. 2 then says, what about a change in the price of the good? So what we just explained is that no, if MyBrew wanted to sell more coffees by offering a discount on its price, that wouldn't move it from here to there. It would move it down along its demand curve. So it would sell more coffees only because it's charging a lower price. So this does not shift the demand curve. And then finally, we look at a change in competitors' prices. So let's say, assuming again that MyBrew is charging 24 Rand and selling 1,000 coffees. And now we find that Vida decides to offer a 20% discount on all of its coffees for an entire week. How would that affect MyBrew's coffee sales? So what we might find is that some people who would have purchased from MyBrew now choose to purchase from Vida because Vida's prices are lower and Vida is a competitor to MyBrew. So what we might find is that for the next week, at MyBrew's price of 24, they only sell 800 coffees because some of its customers moved to Vida in order to take advantage of the price decrease. And so that would indicate a decrease in the demand for MyBrew coffee as a result of its competitor's lower price. And so this does shift the demand curve. So statement 1 is true, statement 3 is true, statement 2 is incorrect, and so the answer is B. 1 and 3 are correct. In question question 8, we're going to look at how the effect of a supply shock affects a competitive market. And then in question 9, we're going to look at what happens when demand and supply are affected simultaneously. So this question tells us that we are working with a market for coffee that has many buyers and sellers, all of whom are price takers. That defines perfect competition. So we know from this that this is a perfectly competitive market. A major storm hits the coffee growing regions, causing significant damage to coffee crops. Which of the following statements is correct? So I always find that drawing a graph for these types of questions really helps. So a perfectly competitive market has a downward sloping demand and an upward sloping supply. We have quantity on the x-axis and price on the y-axis. The market would originally be in equilibrium where supply and demand intersect, so I'm going to call that E1. And so price 1 and Q1 are the original equilibrium market clearing price and quantity. We then have this damage to coffee crops. And so now we have to decide, is this going to change the supply or demand in this market? So if coffee crops are damaged, it's going to decrease supply to the market. And so the supply curve is going to shift to the left. What that means is that if coffee producers continue to charge price 1, there is going to be so many people who would like to purchase coffee at that price, but coffee producers are only able to supply this much at that price. And so there would be a shortage. And it's because of this shortage at the current market price that there is pressure on prices to increase. So this higher market price as a result of lower supply comes about because of upward pressure on prices due to a shortage at the existing market price. So the market moves to this new equilibrium where price is price 2 and the quantity is lower. It's now Q2. So the effect of lower supply is that price goes up and quantity goes down. So now we go to the answers to see which of these is correct. So A says the market supply curve will shift to the right. That is incorrect. It's going to shift to the left. So A is wrong. B says the market supply will shift to the left. Yes. The equilibrium price of coffee will increase. Yes. And the equilibrium quantity will decrease. Yes. So this looks good. C then says the market supply curve will shift to the left. Yes. And the market demand curve will shift to the right. No. So the demand curve doesn't change at all. And so C is wrong. And then D says the demand curve will shift. No, it doesn't shift. And so the answer to this question is B. In question 9, they now ask us to work with changes that are happening at the same time. So we have fires that cause a 30% destruction of vineyards. And at the same time, the Medical School of Stellenbosch University releases a statement to all people in Stellenbosch that a diet rich in grapes promotes intellectual performance. Explain with the aid of a graph the effect of these events on the grape market in Stellenbosch. So explain with the aid of a graph means you need to write and you need to draw. So I'm going to draw first, and then based on what I've drawn, I'm then going to write an explanation. So we start off in some equilibrium where demand and supply intersect. And so the price of grapes is P1 and the quantity of grapes is Q1. We then have these two events that happen at the same time. And so the first one is the destruction of vineyards due to fires. That is the same sort of supply shock that we saw in the previous question. And so the supply of grapes decreases. But at the same time, there is an announcement that a diet rich in grapes promotes intellectual performance. Now, because most people who live in Stellenbosch, or maybe not most, but a large number, are students, we should expect the demand for grapes to go up if it seems to promote intellectual performance. And so demand would shift to the right. Okay. So I've been very intentional about the sizes of these shifts so that I can get a certain outcome when I find my new equilibrium, and I'm going to explain to you just now why I did that. So the new equilibrium is going to be where the new demand intersects the new supply, and that's over here at E2. So what we can see is that these two events lead to an increased price of grapes, but it appears that quantity hasn't changed. So the effect of these two events in the grape market is that the price of grapes goes up, but there is no change in quantity. And the reason why that is because an increase in demand would put upward pressure on price because it creates shortages. So that pushes prices up. And it increases quantity because more people want to buy this product. A supply decrease also puts upward pressure on price because if supply goes down, that would also create shortages. And it puts a downward pressure on quantity. So if these two things are happening at the same time, what we should notice is that prices are moving in the same direction. So there is a definite upward pressure on price. But these two events have opposing effects on quantity. And so the actual change on quantity in this market is going to depend on which of these are bigger. If demand increases by a greater magnitude than supply decreases, then we would expect quantity to have gone up. But if supply decreases quantity by a greater magnitude than demand increases it, then we would expect to see the overall quantity go down. So when these two things are happening simultaneously, we would say that there is a definite price increase, but an uncertain or ambiguous change in quantity. We can't say whether it would go up or down because it really depends on the magnitude of these effects. So if we go to the explanation for this picture, what I would say is that the grape market starts off in equilibrium at E1, where the equilibrium price is P1 and the equilibrium quantity is Q1. The two events cause supply to decrease, so shift to the left, and demand to increase, shift to the right. The overall effect in the market is a higher price, P2, and an uncertain change in quantity. So here I am describing what I have drawn in my picture. So it's important to recognize that when two events, one affecting the demand side and the other affecting the supply side, occur simultaneously, there can be ambiguous changes. So let's just quickly think about another example. So let's say there was a demand decrease at the same time as a supply decrease. What would the effect in the market be if these two things happened? So a demand decrease would pull the price down and it would bring quantity down. A supply decrease would pull price up and it would bring quantity down. And so if these two things happen at the same time, we would say quantity definitely falls, but the change in price would be uncertain, because these two events pull price in opposite directions. Okay, so that's how you would approach a question with two events happening simultaneously, how you would draw the graph, and then the sort of explanation that you could give for that question. Okay, so now we're going to look at a perfectly competitive market using equations for the demand curve and for the supply curve. And then the second part of the question is going to ask us to describe what the situation would be if the price was not at equilibrium. So it's going to deal with this response that the price mechanism has to a surplus or shortage in the market. So we get told that the demand curve for milk is given by price equals 8 minus QD. And the supply curve is given by price equals 12 QS plus 2. And the quantities are measured in liters of milk. Actually, I just remembered this it should be a half, not 12. So that's again a printing error, so this should be 1 over 2 QS plus 2. Determine the equilibrium price and quantity algebraically. So the equilibrium price and quantity are going to be where the two curves intersect. So we're going to solve for this and this over here. So we set these two functions equal, and so 8 minus q equals a half q plus 2. I take 2 to the other side, so I get 6, and I take minus q to this side, it becomes plus q, and so 6 equals 3 over 2q, and that means that the equilibrium quantity is 4. So this is 4 over here. To get the price, I then sub 4 into either of these two equations because it will give me the same answer. So if I sub it into my demand curve, I get 8 minus 4 equals 4. If I'd subbed 8 into this, half times, 4, not 8. If I'd subbed 4 into this, I would have got half times 4 is 2, plus 2 is also 4. So that would have given me the same answer. The next question then says, calculate the situation that would arise in this competitive market if the price of milk is 5 Rand per litre. So just to look at the picture quickly, if the price of milk was 5, that lies above the market clearing price of 4. At 5 Rand, this would be the QD according to the demand curve, and this would be the QS according to the supply curve. And so we should expect to find a surplus of milk if the price is 5 Rand. So we prove this by subbing 5 into our two equations. So for demand, 5 is equal to 8 minus QD, and that means that the quantity demanded at a price of 5 is 3. So this value here is 3. For supply, 5 is equal to half q plus 2, and so 3 is equal to a half q, and so the quantity supplied equals 6. So this is 6. And that means that there is a surplus of 3. Okay, so if the price in this market lies above the market clearing price, there would be a surplus. The market would then adjust by lowering prices so that it ends up where the market clears and QD equals QS. So the market would respond by adjusting prices downwards. So the price would adjust downwards in order to deal with this surplus and eliminate the quantity supplied being greater than the quantity demanded. If the price in the market was below 4 Rand, then it would be the opposite. There would be a shortage, and then price would adjust upwards to eliminate the shortage.